In example 3, we're going to differentiate implicitly. So I'm going to differentiate the x's normally, and then I'm going to treat y as an embedded function and apply the chain rule and product rule when I'm differentiating that y. So here I have 3xy, so I'm going to differentiate the 3x, so I end up with 3. I end up with 3 times y, and because I have product, I'm going to use product rule, so it's going to be plus 3x, and then I'm going to apply my chain rule. That's how I'm going to generate my y prime, the derivative function. And then I'm going to have minus 4x, there's no y here, so I don't need to apply chain rule, plus 2y, but again, because I'm differentiating a y, I've got to treat y as an embedded function. I differentiate the squared. Now I have to differentiate the y, so I'm going to end up with my y prime, and then equal to 0. I'm going to then group my y prime terms. So I'm going to group and factor, so I end up with y prime, and I'm going to factor out my 3x, and then that's plus 2y, and then my other terms go to the other side. So I'm going to add 4x to both sides. To get rid of the minus 4x, I'm going to subtract 3y from both sides. So I get minus 3y. And then solving for my y prime, my implicit derivative is then going to be equal to 4x minus 3y all divided by 3x plus 2y. And this is my implicit derivative in terms of x and y, so I can find my slope if I have an x and y coordinate. Differentiating b, we have to be a bit careful because there are embedded functions and product rule going on here. So first thing I'm going to do is I'm going to differentiate the e function, and I end up with the same thing that I started with. But because that is an embedded function, I'm just going to highlight this here, that xy is embedded, I need to differentiate that part using product rule. So it's going to be 1 times y plus x times the derivative of y, and this is where I'm going to generate my y prime term. Okay, so the blue represents the derivative of the inside function, which is the exponent, and while I'm doing that, that's where I'm going to generate my y prime. So then I move on to the next term, plus, I'm going to differentiate the sign first, so I'm going to end up with cosine, and then xy, but again, I have an xy embedded inside that, so I'm going to differentiate that as a chain rule. So I'm going to, again, get 1 times y plus the x times the derivative of y, which is my y prime term. Okay, so there's my chain rule generating my y prime, and then equal to 1. Okay, so then I need to isolate my y prime. So what I'm going to do first is I'm just going to group that y, the blue part, because it's the same in both terms. So it's going to be y plus xy prime. And that's going to be equal to the product with e to the xy plus cosine of xy is equal to 1. And then I'm going to solve for that term, and then I'm going to isolate the y prime. So I end up with y plus xy prime, and that's going to be equal to 1 over all of that, e to the xy plus cosine of xy. Okay, and then solving for my y prime term, I'm going to end up with xy prime. So I'm going to subtract y from both sides. So I end up with xy prime on the left-hand side, and on the right-hand side, I'm just going to move that y. So this becomes 1 over e to the xy plus cosine xy, and then minus y, and then I'm going to divide everything by x. So my final implicit derivative is y prime is equal to 1 over x e to the xy. Now I could keep that x factored. I'm just going to, in fact, maybe I should keep that factored, plus cosine of xy, and then minus y divided by x. Don't forget to divide that by x. And again, we can keep that separate. We can combine those fractions if you want, but this is going to be good enough. It is fairly easy to use, so we're going to leave our implicit derivative like this.